Jason have a very interesting background, I would say. Now he's heading Ericsson's cloud operations, and but he has also started a lot of companies. He has been an investor or is an investor. So you have a lot of perspective. And now you will talk about cloud and internet, what is happening and what will be the business in the future. So I'm very happy to have you here. And so the floor is yours. I think we are almost there now. Yeah. So if we
can raise the screen up as well.
Yeah.
Is that sort of, oh, you can hear me now. Can you hear me now? Perfect. That may not be a joke for everybody, but that's Verizon's commercials in America. Can you hear me now? Can you hear me now? Yeah. So thank you very much. I mean, this is exciting. I mean, I was told it was going to be in a lecture hall. I haven't been in a lecture hall in a while. So I thought I wouldn't show slides. I'm actually going to use a little bit of the board as I need it, because back, for example, when I was teaching at UCLA, we didn't really have computers or PowerPoint. We used chalk and foils in that, so it actually feels a little weird to use a computer in a lecture hall for me. But no, as we said, I mean, I've been with Ericsson for 2 years now. You know, the idea was to come and help with a few things while simultaneously, hopefully, retiring to delightful Sweden, actually. So, because I still have 3 daughters from 15 on down. It's, by the way, a fantastic place to raise a family. So, came to Ericsson a little over 2 years ago to start helping with what it meant for Ericsson to go into infrastructure more broadly. The company, of course, as you know, does design, build, operate, and support mobile network infrastructure for mobile network operators, and that's largely the activity. The idea here was maybe we could do infrastructure, and is there even sort of a reason why? Is there an eraser somewhere? Right. This? Oh, camouflage. So we'll talk about 3 areas. The first one is at least what I think the next 20 years is going to be from an infrastructure standpoint. The short version is it's like the last 20 years, but a little in reverse. So it's not rocket science for how we figure that out. But we'll talk about you know, the next 20 years. The second area is then really the mere phenomena that's happening to this digital transformation we talk about very much. And that is that type of transformation and the needs of the next 20 years from an infrastructure standpoint means that we have to start taking a industrialized approach to infrastructure like we never have before. As you know, we're already getting to the point where data centers are taking up almost double-digit % of our total energy consumption globally. And the number one thing stored in them right now is selfies. That's what's in it. We occasionally refer to them as global repositories of human knowledge, but number one is selfies. Do you want to take a wild guess on number 2? That's number 3. That's number 3. Yeah, the cat thing's funny because Eric Nakagawa that started that, actually, oddly enough, was a good friend of mine back then, and I thought it was the stupidest thing he ever did. Because the one funny thing about, so I'm from San Francisco. The one funny thing about being from San Francisco is it's only the town's actually a little bit smaller than Stockholm. There's only about 800,000 of us in town, and there's only 2.5–3 million in the whole Bay Area. So it's also that might be rude if I say that, but it's also somewhat inbred in the sense of lo and behold, your neighbor all of a sudden is going to work in a jet. But this industrialization part, and then the third area is really sort of the enablers of that, because whether we realize it or not, we are a bit in a hardware renaissance, and that's whether we're making our own things and doing this to a wide range of different types of chips available. The idea that Raspberry Pis aren't a quote-unquote toy, these types of things. And even though we like to say things like software is eating the world and hardware is a commodity, and we sort of do this, we do go through these continuous types of cycles where software hits a certain limit, and then hardware has to innovate, and then software builds on that, and hardware has to innovate. And that does interplay a bit with the industrialization aspect as well, because we have to resist the urge to continuously add to things, right? So these three areas. So the first one is, I started out my career, I guess, in computing, in scientific computing. And if you go back then, scientists and accountants who were the people that largely used computers 20, 30 years ago. We used them as big calculators, effectively. And particularly in scientific computing, you always had this discipline that you had to make the best calculator for the cheapest price because you're typically sitting on a capped grant. You get $78 million to build a supercomputer, and you wanted to do the most you could possibly do. And so we're gonna sort of park that as a little bit of a principle, because that principle never showed up in enterprise IT, for example. Right? That it's like whatever, $100 million SR, ERP system, whatever type thinking. But it's the scientific computing thinking that's shown back up again, right? So we started out there, and then we had the web show up, roughly 1995 or so, and we had a number of little sort of web servers sitting there, and it wasn't complicated. We're talking about the consumption of documents. I mean, like reading things. And then it became somewhat bidirectional, where we wanted to at least comment on the things that we were reading. We even wanted to say annotate them. Occasionally, we even wanted to talk about it, and we didn't want to go to a new phone. I mean, we wanted to just use the computer to do that. But the reality being that off over here, oops, I'm misspelling humans. That's disconcerting. We have humans talking, messaging, and then consuming media. And I mean that broadly, the watching of a video, the reading of a PDF, the looking of a PowerPoint. Those are our workloads. It's talking to one another, it's messaging one another, and it's the consumption of media. And we've seen, for example, that we talk about the same. We've started messaging a lot to one another because we broadly message to people, but we only like to talk to people we like. And then we're consuming media at unprecedented amounts now. And there was really actually only one industry that was disrupted by this, and that was advertising. So every model that basically showed up here is advertising. We do have some people that still did direct pay. You directly pay Netflix to not have to read ads, but everyone else is advertising in that. And there were a number of people that basically built platforms, and largely the platform players have won this. And when I say a platform, I mean somebody buys something from you, you give away something for free, and you get people paid. And if you manage to do all all three of things, you have a platform business. So Google is free search. People pay for AdWords. People get paid through AdSense. Facebook is free. People pay for ads. People get paid through the Facebook API. You know, and so on like that. Yeah, and under the direct pay, you know, by the way, I include retail. And so we see these types of things where the idea that we give away something for free and we get people paid, these amplify what these people do. And so a lot of the players that have largely won in this space, they had amplifiers that other people didn't have. This idea that you just buy something. But we're starting in 1995. Little web servers starting to consume things. Now more people want to consume it. Tens of millions of people start showing up on this thing called the internet. And we have these human beings out here, and this is the best I can draw them. But I can make them smile. And we have here in the center, we have this type of thing where all of a sudden this entire mechanism really started by like a company called Akamai shows up to help distribute this content closer to the people, and it shows up in tens of thousands of locations. Now the 10,000-ish number is an interesting one, because if you looked at like standard, say, fiber connectivity, which we have now, but we didn't have then, but if you look at what you could do in the speed of light, every kilometer is about 5 microseconds of light moving. To be within a millisecond or 100 milliseconds of somebody, which is about what the human wants to see when you consume content. You know, it loads up in about a second. You need to be within 200 kilometers of somebody to do that. If you draw that as a circle and you draw a square inside of it and you fill out the area of that square, and then you tile the world with about 10,000 squares, right? So it's about 10,000 squares, about 200 kilometers wide that it takes to cover the world. And then if you want to get down to like, you know, 100 milliseconds, then you need to be in the range of 10,000 to 100,000, you know, sort of sites. So it's really this type of idea that somewhere between 10,000 and 100,000, you know, you're within 100 milliseconds to 1 second from an eyeball. And so we see people like that, you know, basically begin to show up. And then all the middle mile guys start building out a ton of infrastructure. We had a massive broadband explosion and then collapse, 2001, 2002. And then when people like Amazon, I can't spell today, Microsoft, Google, decided to build their own CDNs for people reading materials like that, they built them very centralized. So around 2006 to 2008, as these guys were building it, they were, say, up to 100 sites. People get somewhat surprised when they learn that, you know, Google's just built their 13th, 14th, and 15th data center. There's only 15 of them. And even when you look at the own content distribution systems, we're talking about like 68 sites globally. So even though it responds great and you use it, and they're supposedly huge, less than 100 sites. And then we had mobile show up with the iPhone. Well, it's not quite fair to say it showed up with the iPhone, but it really sort of took off with the iPhone. And mobile application delivery required something that wasn't here and wasn't there. And then you had companies like Edgecast show up in the middle that was in 1,000 sites type things. But you had this sort of thing. These humans wanted to consume voice media messaging. This had to show up. This had to show up. That had to show up. And that had to show up. Meaning edge, connect it all, centralized, middle, right? Now, the world that we're heading into now is not centered around humans. We've decided, for example, that perhaps in this type of thing, we have a new user. And so when we look at the new user of this is machines. We call them sensors. We call them, you know, the embedded little modules inside of cars, but that sort of thing. It's machines. We've decided that we've now can go out and instrument the world, and we can instrument humans, hopefully for the purpose of maybe these technologies doing something more than selfies, cats, and food, right? That it can maybe do more in that. Now, the fascinating part about this is machines do not talk to one another. They don't text lol in that or send selfies, and they don't watch videos, and they don't click on ads, right? So what they do is you basically sit down and you do data collection. The idea that we collect data from the world in that. And then occasionally, not occasionally, but almost always, we want to do something with that data. And then the question is when you want to do it. Do you want to do it very quickly? Do you want to do it whenever? Do you sort of keep you know, that going? If you want to do data very quickly, or you want to sort of loop back and change the behavior of the device, then you're now doing a control system. So we're at this funny point in time where humans aren't the end users, machines are the emerging end users. We've decided to collect data from the world. At some point in time, we look at that data, and if we say, hey, that device isn't behaving correctly, we should change the way it's behaving, and now we have a control system. So the three use cases before, voice, media, messaging, now become control systems and data collection. So there are only two, and people call it machine-to-machine or IoT or connected cars or sort of whatever you want, but we have a chip somewhere where some event data gets generated, we collect it, we keep it as a time series, and we analyze it. And sometimes we go back and tell the device, do something different, right? So we have there. Now, the funny part is, what industry does this disrupt? We don't make new industries, right? We don't make new industries. Advertising existed before Google, it existed, you know, still exists today, and so on like that. We as humans, we're pretty sort of like straightforward in there. Now, none of us are really sure. The closest thing we can get is maybe it disrupts something like insurance. It's already touching supply chain, transportation, logistic industries quite a bit. However, when you look, supply chain, logistics, distribution really took off, meaning we got rid of people like longshoremen packing up boats when the containers showed up, the pallet showed up, the container ship showed up. But most importantly, when the certainty of your ability to deliver something could be insured, right? But right now, nothing in the IT space is insured. You know, if you went off, for example, to somebody like Lloyd's and said, hey, how much would it cost for me to get, like, I don't know, a $4 billion cyber liability policy for my enterprise, the usual response is that it would cost about $6.5 billion to get a $4 billion insurance policy in there. So what the insurance industry is actually telling us is that they think that we have a 100% likelihood as an enterprise over a decade of having a event of significant liability that they can't make their 6 to 15 points on that, no thank you, right? So the only thing maybe is basically like insurance, but the platforms that show up, who knows what those are. Now, the funny part is if we think of this again as a mirror, where now we have, I don't know how to draw a picture of a machine. I mean, maybe a square human, so it looks like a robot, like that. But we have machines, and right now, most of these machines are going off and sending their data to someone like Amazon Web Services. people that are out there playing around in the IoT space and doing some data collection are prototyping those a lot on very centralized types of infrastructure, right? Yet the funny part about this is when you look at some of these types of data collection ones like that, there are single data collection use cases, single data, data collection use cases that are larger than the traffic of something like a Netflix. What happens when there's 1,000 of them? Right now, the entire infrastructure we've built handles a Netflix and a Google, YouTube. Like that's all it handles. We sit in some markets. You have extreme examples like the Netherlands where something like 80 to 90% of mobile traffic is Netflix. You head into some parts like the United States where 70 to 80% of traffic in the evenings is Netflix. And that's of capacity. So we have this thing coming where these are very centralized. It's unclear what the business model is going to be to build out this capacity. Yeah, 5 minutes? Yep. Oh, okay, all right. It's also sort of unclear that one's going to go and do what's next. And then it's also unclear who's going to go and do what's next. Right? Now I'm only on topic number 1, so we can hit these topic number 1, it's a front-loaded talk. I mean, so the key around the industrialization aspect is you start looking at these lessons from the Googles and Facebooks and so on of the world, scientific computing, of how do you begin to start building an infrastructure where your fundamental offering is free, right? So it means that in an industrialized infrastructure approach, continuously improving unit economics of that infrastructure is the driver. The ability that every 2 years you can make it cheaper, 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 cheaper. It should not be surprising to any of us that somebody like Amazon, an expert in supply chain, distribution, warehousing, understanding why people buy, could offer a virtual machine in 2009, and then 4 years later offer it for 80% cheaper. And yet when they reported their numbers, they were still very profitable on that VM. Because in that same period of time that most of us keep a server, they took 96% of the cost out of delivering that virtual machine. Supply chain thinking. So, when we look at the enablers of this type of thing, we're heading into a thing now where chips are, yes, a quote-unquote commodity, but the first one is the default chip you'll see out there in the near future. The majority of them that will be shipped will be custom. So you have a custom foundry effort going on. Even Intel's business around custom foundries exploding. So the ability to get a little chip for the exact right price that just does exactly what you need, that's happening. Silicon photonics in the data center, big area. The ability to start going 100, 400, 800 gig, 1 terabit per second, stay in the same little form factor, keep the cost of that the same. Silicon photonics, big one. Okay? And then when we start looking at this from a software perspective, the thing that's incumbent on all of us as software engineers is not the action of putting more things in, but the act of taking things out. So when we look at even the sort of popular rise of containers and things like that, it's about taking things out. It's not an operating system on an operating system with the full VM, with the full sort of layers. A lot of the activities that we're seeing is minimizing sort of like all the way down. And we started doing this like previous team I ran was we did like a semi-popular runtime called Node.js that a lot of people use. And that's a great example. And then another sort of like little sort of small messaging core where when you would take something like a full-blown messaging engine and something like Java, you'd be looking at about a 1 gigabyte sized application about a 0.5 gigabyte size messaging bus. And we're sort of back to, how I remember it when I was younger. This idea that it's okay to make an application that's a megabyte in size, and it's okay to make a messaging system that's a megabyte in size, because with this explosion, we're going to have to get much more efficient. That's it.
Okay, thank you very much. So, I guess we have some questions now. Questions?
It's okay.
It's okay.
It's okay.
Yeah.
It's okay.
Yes. Hi. Nicolas Sevier, actually work in Ericsson. But, yeah.
Hi.
Yeah. We've met once. But
Yeah.
how is it that it's so difficult to explain this change in the industry in terms of minimization and the change to more machines? Why is it so? Why so many people are resisting this idea that you need to go towards things that are much simpler, more efficient, and more distributed, and move forward with that, and stop resisting it, and just that's what's going to happen. What's happening now? And
Now, I mean, for me, it comes down a bit to just how we are as humans. So you're more likely to find a human that's what we would call a pack rat, right? People don't tend to throw many things away every year and so on like that. So as humans, just as I think our basic biological makeup, we're pack rats. And we don't always like to clean up, and we don't always like to finish our dinner, and we don't like paying off debt, and we don't like taking out the garbage, and so on. And we have technical debt. We even build garbage collectors and runtimes. We do these types of things. And so this idea of taking almost an overall design philosophy of minimizing, simplifying, and still getting to something that has a certain degree of elegance. That not only is a rare trait in the furniture industry, it's also a rare trait in computer science, and you have to decide to do it on purpose because we're just sort of the most advanced primate on the planet, but we're still largely running around consuming fruits and pooping where we want and sleeping when we want to, and we have to work at it. So I think there's a little bit of a basic type of aspect there. The other one is that it's very difficult for people to understand distributed systems without working on them. Meaning working on them just in that. This idea that what is it like to have everybody in the world as a friend on Facebook is a distributed type idea. So meaning we tend to even think of centralized systems versus decentralized systems versus distributed systems without sort of understanding that the distributed system is a superset. That if you build a proper distributed system, the other ones you can basically apply a policy to it and the other behaviors fall out. Now, when we look at the creation of these types of systems, they're very difficult to create from the beginning. The fact is when you're sitting there and writing software, it's much easier to understand a completely monolithic application. It's much easier to correct your errors in it. It's much easier to correct your mistakes. And so we go and we make a monolith. And unless there's operational pressure applied to it where stuff breaks, then we basically don't start breaking it apart and we don't start doing it. So I think it really comes down to the fact that many of us are messy pack rats. And you have to be sort of the type of person that has like a section of your home where one of your goals is to make the old hardwood floor just perfectly flat and perfectly smooth and have the grain pop up. And you have to have that type of mentality, even though you're sort of working with software. And we do actually have to work at understanding what it means to create something that's distributed from the beginning and good. And I think it goes against just sort of what we're comfortable with. Yeah, even though it's the right thing to do.
Okay, thank you very much.